The chairman of this session. Dr. Mladen Todorovic will give a keynote speech on the topic modern approaches and tools for irrigation management, from research achievements to on-field applications. Thank you.
Okay. Thank you, Mr. Chairman. Good morning. I'm coming from this institution, from SIAM, Mediterranean Agronomic Institute of Bari. Many years ago, the challenge was how to transfer scientific knowledge from one scientist to another scientist, because 20 years ago we didn't have internet. There was much less researchers around the world, and we had to use for hard copies of publications. One example is, for example, water use efficiency concept that was developed in 1958 by Professor David. But only in 70s and 80s it has getting importance. Another example is Perman-Montit equation. So Montit contribution was in 1965, but only in 80s and 90s this scientific knowledge has become widespreadly used by people. Now, having a lot of new facilities, having internet, having new papers, scientific documents, a lot of conferences, the transfer of knowledge from one to another scientist is not a problem. You know that water productivity or virtual water terms or different nexuses are becoming important almost immediately when they appear in the scientific world. So I'm going to speak about now something that is much more complicated in the field of agriculture. How to transfer this scientific knowledge, how to transfer approach, how to transfer models on the field. And I would like to present, if it is working, but if it doesn't work, I will use this one. I would like to use, in brief, this new program of European Union, that is Horizon 2020. And if you go to see, this is extremely important and rich program with more than 80 billion of funding available, and even it will be much more than that in the future. It should focus on the transfer of the knowledge and achievements to the fields. But there is in between something that is important, that should create economic benefits and should create new jobs. But only one part, very small part, probably some of you can tell us how small is this part, is dedicated to agricultural sector. And why it is like that? Because if you go to see, for example, if we are speaking about water, if we try to compare urban with agricultural sector, we are going to see that agricultural sector, in terms of implementation, is, I would like to say, problem-making sector. In respect to urban sector, it is much more profit-making sector. In agricultural sector, we have greater demand several times, but in urban sector, this demand is much easier to predict than in agricultural sector. In urban sector, supply and demand are easy to control, estimate and measure. We have controlled systems. This is not true in agricultural sector. Urban sector does not depend on external factors. There is very simple stakeholders relationship between provider, water supply managers, and users, that are citizens. In agricultural sector, we have a lot of stakeholders that are taking care about water. And we have a lot of external factors, as it is climate, as it is soil, that are changing, especially climate, in time and space, and soil space. Price of 1 cubic meter of water is about 5 to 10 times greater than the price of water in agricultural sector. And those consumers appertain to higher social classes are able to pay, they are paying regularly, there is strict relationship between them and providers of the system. All this is not true for agricultural sector. And what we have also to say that urban water supply is something that is compulsory, and this is a priority. Awareness about that is very high. Awareness about the importance of water for agriculture is not adequate, and we should to work on that. So, if you see all that, it is clear that small part of the money will go into improvement of urban water use, rather than in the improvement of agricultural sector. Again, I'm using. I would like now to say in few words what we have and how it is complex, our agricultural sector. What we have, two the most important groups of people working are agronomists that are going to apply some agronomic measures, and we are going to scale up those agronomic measures and to reach water demand. And then engineers on the other side are going to take water from some source and they are going to distribute it to the users of farmers. It is complex concept, but this concept still is working until it is remaining inside just relationship between farmers, agronomists, and engineers or water suppliers. So inside this concept, if we understand that water demand is something that we can estimate it as a difference between crop evapotranspiration and effective precipitation, divided by efficiency of water application, and on the other side, we can try to satisfy it through the supply, we are going to understand that our water withdrawal, whatever is the resource, is something that is the ratio between agronomic demand. We should try to reduce this agronomic demand through some measures, and engineering efficiency, we should try to increase it as much as possible. More water we are withdrawing. Usually in that period, demand, when it is high, water availability is very low. So this is another problem that we are going to have. But we are not living and remaining only inside this relationship between agronomists and engineers. We should consider environment around that. So all those who are taking care about environment, and we should consider social economics and policies that are going to play between social and economic factors. In developed world, and even almost everywhere, nowadays, economic factors are much more important. Before we spoke about socioeconomics as a unique word. Nowadays, we are speaking mainly about economics, and we are speaking very little about social aspects. Anyway, we should follow some policies that are going to be behind that. And how to consider all this? It is the way, the approach that is today suggested by the European Union is mainly to go into the coupling of economic activities, gross domestic product, and environmental impact. So indicators of environmental burden. And we consider it in the time, the objective of whatever is a new advanced strategy or tool that we are applying should be to provide economic benefits and in the same time to reduce negative environmental impacts. So this is the concept of eco-efficiency. And this concept of eco-efficiency is basically the ratio between product or service added value and environmental impact. And inside this ratio, product service added value is the difference between service or product value and cost of production of that service. And on the other side, we have environmental impact that in brief we can say this is related to water withdrawal, energy consumption, CO2 emission, fertilizer inputs, and so on. So this is a new approach that we have to follow today. And this environmental impact is coming out through a sort of composite system indicator considering all these different factors. Now let's go to see what are those eco-innovative technologies. So we can consider those technologies that can improve water productivity, energy efficiency, and ecological effects. And if you speak about water productivity, we can thinking about the remote automated control of irrigation, water supply, devices to control water withdrawal from aquifers, monitoring soil plant atmosphere continuum, provide better irrigation scheduling, more efficient irrigation techniques, so moving to drip subsurface, changing cropping pattern, use of treated wastewater, and so on. About energy, we should consider solar-powered irrigation pumps. You can see that farmers, at least in Apulia region, if they have to move, or also in other Mediterranean areas, they are going to move from diesel directly to solar. They are not going to use electric pumps, although they are more ecologically clean, because of the problem. The problem main is the way how to connect to the electricity network, and because of high costs of this connection and maintenance. So, eco-friendly variable speed pumps, network sectoring and dynamic pressure regulators. And then, if we are speaking about let's say eco farming, we can use biodegradable mulches, application of minimum tillage, changing cropping pattern, organic farming, and so on. So these are some of the measures. And I would like now to go to show you some examples. One of the examples is a hydrotech project, one of the projects that was funded by European funds for rural development, and the Apulia region. We completed this project several years ago, together with CNR ISPA, together with Director Lab, and together with Sisman, who was the coordinator and the main developer of the system. He said we tried to integrate and automate almost everything that was possible. So what we have on-field devices, we have weather stations on the field, we have soil sensors in the soil, we have also user devices from where the system was controlled, and we have our group of computers that are performing all analysis, and they are helping to the user to get all information through the data cloud, and then to send it directly into the field and to activate electrovalves and to act directly on the system, opening and closing the valves. So it was something that was done several years ago, and inside what we tried to do, it was to combine something that should be, let's say, the main achievement that any system should do. Combine modeling and monitoring. Because we are speaking about inexact system, very approximate system, as it is agricultural system. And we try to monitor something. We know our monitoring results are not so perfect. And we know at the same time that modeling is not so perfect. But the way to understand better measurements and modeling results is to compare them and to understand which of them is going to be more accurate or not. We are going to use different approach for estimation of reference evapotranspiration, because depending on the available data inside the software, we can decide if we are going to use permanent mounted equation or permanent mounted only the temperature data or whatever is the other method. We are going to apply adjustable also coefficients for solar radiation, and we are going to check also KC values for local conditions, because we have KC from the literature, but we have KC values that are reflecting the real conditions of the field. We are going to use multi-crop development model. We know that presently in the past we simulate everything using day-by-day approach. But nowadays we apply also here heat units as the way to estimate the development of the crops. We apply also multi-crop response to water approach. So we did not apply only Stewart equation, but we applied also Rao equation, in which we are going to use different sensitivity of crop during different growing stages, and to use a multiplicative approach to get yield losses. We apply weather forecasting because today it is available from 3 up to 7 days. We then use different approach for irrigation management, try to completely or partially automate the system because it depends on the conditions in the field. We have real-time remote control and management, multi-plot crop management. So we go on the farm, we could have different crops grown and different fields. We should have a limitation of water availability, limitation of the hydraulic characteristics of water supply, and on the basis of that, we develop an optimization tool that can help us to manage our water supply on the best possible way. So, then we use and follow different on-field specific management strategies that could be developed together with the users. We apply eco-efficiency concept, and still we say this is something that could be improved because this is a system in which you can insert new pieces and connect with the rest of the system. Here, some examples of application. Some examples in Apulia region, we did many other examples. I don't have now here a map with additional applications, but these are some of the locations where we applied in Apulia region for different crops, as you can see, and different management practices. In the meantime, Hydrotech evolved from something that was a Hydrotech as a project into something that is a commercial brand, as it is Blue Leaf. And this is the website where you can find new data about this. In brief, examples of installation of weather station. You see it is installed in the field, but those conditions are not standard conditions. So what we are getting are not perfect data. We are going to use here temperature and humidity that we can say that could be adequate. Precipitation could be adequate, but usually we don't have enough fetch that we can accept wind speed values as a good one in this estimation. So there are a lot of problems. In the case of soil, you see we try to put it at 2 depths in order to be able to understand if we are giving more water or less water than necessary. But there is a lot of problems because it is very difficult to have really good measurements of soil moisture. It is becoming, it has been a problem for many years, and this is something that will remain a problem in the future. Another example, when we are going to automate engineering part of the system, that is closed system, we can say we have less problems because if we are going to monitor pumps working and also hydrants release of water and discharge, we have much less problems because this part of the system is more exact. Here we have applied something that is a sort of a new device that was developed by ITG. This is also one Italian company that is using this type of the system to transfer data from one hydrant to another. And this type of the system is using the radio part of the band to transfer the data and doesn't need GPS. So you can go in remote areas without any cover of mobile phone, and you can get data from that area, or you can send data into this area. Now, there are some examples. Example application at the district scale. So here you see these are some hydrants. We are here close to our institute. You see these green hydrants are open, these red hydrants are closed, and you can directly, or through your mobile phone, or through your computer, close and open each of the hydrants. You can send order to say where to irrigate. You can program your irrigation from that hydrant, telling that you would like that this hydrant irrigate 10 cubic meters starting from 12 o'clock until 2 o'clock and so on. So you could have full control of the system at district scale. This is the way how you are going to connect, and you can do it. Even if you are in Milano, you can activate system in Bari, or if you are in China, you can do the same. This is advantage of our time. Examples of application at farm scale, you see at farm scale we are going to have different details that are related to soil sensors, to weather station, to the main electro well, activating the pumps, and so on. And we are going to go into the system to decide which field is going to be irrigated and when. So, when you go more into details, you are going to see how we are developing soil-water balance. This is the part of the forecasting that is given here. You can understand here that we are entering into water stress, so you can prevent water stress planning exactly when you would like to have irrigation. And this is something that is running, that is working. And this is application on the mobile. Android, you can start from here, you enter inside in the system. If you find a red color, it means you have to irrigate immediately. If it is a green, you don't need. If it is something like orange, so you are in the alert, you should start irrigation. And you see all data that are inside here that you can check. Modeling part on one side, and on the other side, you can check also what is going really on the field. Because we are taking and receiving data related to the weather, and we are also doing the same for soil moisture. Some examples of application. For example, one of the examples is given, it is related to sensitivity of water stress in different technological stages. Here, what we are going to see, it is the no stress between bud and burst and flowering. So we are going to keep coefficient of stress high. Then we are going to accept a sort of moderate stress until there is some phase. And we are going to go into more strong stress when we are going to arrive to the end of the season. So we can regulate the level of water stress. This is an example that we applied and used on vine grape in one area in the province of Brindisi. It was done in agreement with our user, with the farmer, because when we are speaking, at least in Apulia region, about agricultural production, it is moving from quantity to quality. So the quality is getting more importance than quantity. And we try to follow this strategy. This is one of the examples. Another one is related to peach. You see no stress between flowering and hardening. And then what we have, it is that we allow moderate stress during vegetative development stage. Then we are going to stay without stress during the fruit development stage. This is the important period. And then to allow a sort of moderate stress when we are going to post harvesting phase. So this is the approach that we arrange and that we apply for this particular case. Now I would like to show how it is looking inside our system. What I would like also to mention, that in our system we are going to differ between readily available water, that is a sort of threshold that is usually applied to say as a threshold for starting a stress when the plant is going to really reduce stomatal opening. But we apply management allowable depletion that is going to be different, and this is something that does not follow readily available water. Let's go to see one example when we compare our results with those that are coming directly from the field. We are going to have something like 15% of water saving. In this particular case, we are still speaking on a peach orchard close to Brindisi. And here we presented a sort of eco-efficiency assessment for the first case and for the second case, and we are going to show how some parameters that are related to water saving or that are related to energy saving are going to be more efficient. So we have 15% of water saving. At the same time, we have something like 9% of energy saving, and we have also something like 10% of CO2 emission reduction. So this is one example that we applied, and these are some testimonies of these success stories. These are testimonies of one of those farmers who is telling that this system is really something that he needs, and another one who is also telling that some saving of about 20% could be achieved using the system. And they apply this system, these two farmers and many other farmers, already for 3 seasons. But now there is a question. Okay, they are going to use it. We invest our time, we invest our resources, but who is going to pay maintenance and future operability of the system? And then we are returning at the beginning when we are speaking about urban sector as a rich one and agricultural as much less rich. Just one more example to show scaling up to district level. In brief, just to show you the concept that we applied when we are going to go into district level. This is very simplified example of Sinistra Orphan irrigation scheme. This is a scheme of 38,000 hectares. So we are going to enlarge a lot with about 20,000 farmers. And inside we are going to have all inputs that are coming from background system, to put them into the water system, to distinguish between different actors that we have, environment and water resources authority. Then we have inside water supplier, that is irrigation consortia di bonifica, di Foggia. And we have 3 farmers associations, each of them independent, that is going to manage their part of land. And inside all this, so big system, inside this project, EcoWater, we have developed a way to estimate eco-efficiency of this big system and to estimate eventual improvement of eco-efficiency in the case if we are going to make some change, make some advancement inside the system. So this is the way how we try to apply it on the larger scale. I'm not going to do details about that, say, years to come. The most important is, today we are about between 19 and 20% of cultivated land is irrigated. It is producing almost 40% of food demand. So we are going in the range from the 20% or 19% which is 20. In the 50s, we will have to increase irrigated land just by 1 or 1.5%, but to produce 44%. So we must look on the way to become much more efficient. And this is something that is known, at least at the FAO. But you see that water for agriculture will be reduced, energy will be reduced, will be increased, the use of energy, but water will be reduced. Not important to go more in details about that. Let's go to see many other things that could be important. The most important is that we are going to have the whole degradation of the system, that the type of community will become different. You remember the first slides that I'm telling urban and agricultural sector, what is going on? That people from agricultural land are moving into the cities and become urban population. They're going to cultivate something in their small balconies and so on. So we are going to live in a completely different world. Very unstable world. But anyway, adaptation of technological innovation in agriculture is something that is a must. That is a must, but who is going to fund this must? The must, because the way forward, if we are today somewhere here, that we have low economic performance and that we have also low environmental performance, we should try to move more into this direction of this graph. So we should try to become more environmentally efficient, and we should look on the way that doing that we are going to also earn more money. Somehow to earn more money. But from agricultural sector, again, this is the question. Who is going to pay when farmers are usually expecting incentives? Who is going to pay when system should be maintained, because system cannot be stable every year? You have at least to clean it. You have to calibrate it. Who is going to pay for that? And another point that is important in the future is to move from linear into circular economy. What we have still is the linear economy. So we are going to take resources and we are going to also waste resources and we are going to go in this direction and so on. But nowadays, we should look to arrive to zero waste, to make a system in which we produce, everybody is happy, we are distributing money, and the waste is going to be zero. I put exclamation and question mark about that. Is it possible? Or something that is probably more related to agriculture that we can call bio-based economy. Economy, it is, let's say, circular, but it is supported by biomasses and green raw material that is coming from agricultural sector. Probably this is the way where agriculture should go in. I think I arrived to the conclusions. Technologies are made to be effectively applied. Potential users have a real need to apply those technologies. So these are the facts. But innovative solution should be tailored for specific conditions, socioeconomic, environmental, and cultural and political. So for each location we need a different solution, and we need somebody to fund those solutions, but not just to fund implementation, to fund operation and maintenance in the future. Ongoing implementation of this require reliance and continuous dialogue and exchange of ideas between technology providers, potential users, and funding agencies. So dialogue is necessary. We have developed hydrotech. We are now working on Blue Leaf together with farmers and the users. We have become friends. This is important, to have real feedback when we are going to apply scientific achievements on the fields, because you are going to apply on their own fields, on their own level. New solutions, as I said at the beginning, requires integration of monitoring system and management tools at different scales and decision levels, and full involvement of all pertinent stakeholders, because when we are speaking about agriculture, everybody thinks to has a right to say something, to participate in discussion, but not to participate in funding of that. And we should have more demonstration actions, or we should look for some sort of legal action that is going to push on the application of achievements in agricultural sector on the field. So this is all that I prepare for you. Thank you.
Thank you very much, Dr. Todorovic, for this inspired presentation. Also, thank you very much for keeping the schedule. And if you have any questions, please. Yes.
Thank you very much, Dr. Mladen, for this very interesting demonstration you have given about the new technologies and its impact on the development of agriculture in general and the water resources in particular. What I am seeing is that all this technology which is now in our hands, this will help a lot. The researchers, they will set the time, they will help them to take the decisions and to find solution of the arising problems which are facing day to day. But the crucial point, how to transfer what this know-how to the users. This is a very big problem, really. All these technologies really saved a lot of time and a lot of efforts which have been done before in the research, and will give us very good results which we can change together. But all the things, the final thing of this is that to transfer all this know-how to the users to improve our water resources and our agriculture. That is the crucial point, and I want to hear from you your opinion, what we have to do as researchers. In the meantime, also the decision makers are not keen, not aware about what is the new technologies is supplied nowadays. How to let them be on the line with the researchers? Thank you very much for you.
Thank you, Professor Atif. I fully agree with you. So the problem is also that in many cases, as it is the case of Blue Leaf, we are working with a lot of small farmers. So we have in Silistra often 20,000 users. So we should look on the way to create a sort of dialogue through decision makers at a regional level, or at least at the level of consortium, to work on the adaptation of similar system on the fields. In several cases, as it is this figure is showing, we are working with farmers who are real businessmen. So for them it is easy, they like to pay because they know they are receiving adequate salaries. But there are farmers that have 20, 30, 100, 200, 300 hectares of land. And they are living, their families and other people are living on that. So in that case, we can do it, but this is only few farmers like that. So we should look to increase awareness of decision makers and to ask somehow the way that they support not only the implementation, but operation and maintenance of the systems. Because in the world of agriculture, it's not enough just to change a law. You should go every day in the field and check how it is working. You should clean, you should calibrate. So this is something that requires full involvement. Probably, for example, regional authorities could think about the way to fund a program in which young agronomists and young engineers are going to have it as a first professional activity, to go in the field, to follow those systems, and to help farmers to improve their production and to improve eco-efficiency. It is good for young people, young professionals, because they are going to learn and to be in direct contact with the farmers, with the land and resources in their region. And this is also good for farmers because farmers can allow that system is installed, can use it, but they cannot settle the system. And they cannot do many of operational things that are necessary during the season. That's all.
Thank you for your interesting presentation. I fully agree about your nice view in the conclusion. I support this idea that we need more demonstration action in a large scale in a European workshop on irrigation area, where is included also Puglia, together with the Basilicata. So I think this is the way, but we need to scale up the system. We need to training technician, farmer, a bit together in the field, but in a large scale. I think, I don't know if your system, the decision system, was really well. If it was, I know very well, because I made some change some years ago, because there was some mistake on the program. And there was a new version that now is full expanded in all the region. And why this system is not applied till now? In Basilicata is not applied. We suggest that in order to remove some error, some needs of implementation, we need to stay together in the field. Because if the farmer can constatate that does need to irrigation and the program say give water, then we lose the trust from the farmer. We know very well about this. So actually we need a demonstration action in a large scale. And so I fully agree with your conclusion and your nice view about this. And only one question, is just taking a question. You show the deficit irrigation in the second stage of fruit trees. I'm wondering, it was too long this stage. Do you remember the pitch, what it was the harvesting time, and how long was the pit stage, pit harvesting stage?
It was something like 1 month, something like that. Because I don't know how now to move back with this system, so I have a problem.
Okay, was just
because I can just
wondering because
this is something that we follow in a dialogue with farmers and with agronomists who are experts in this part. So they suggested this strategy, and it has demonstrated to be go just because the point is what we have. This advantage is to go and to stay directly in the field. We have interaction on the system. We have give opportunity to farmers to go in the field, make a photo, send to us, and we insert this photo inside the system. So we can see the photo. On the basis of the photo, we can advise what is the time when the fruit maturation stage started. So it is something that depends from year to year. So, but this is something that we get as information directly from the field. And this is something that so on the basis of that, we decided this part. About the system, Blue Leaf is presented even here at this conference. On the back of this building, there is a stand where Sisman give opportunity to everybody to go and to learn more about the way how to use the system. Of course, that we are available for wider use of the system in other regions. It is something that is our goal. This is goal of everybody. That is because number of users should be increased. Now we have something about 20 users, 20 farmers actually, but it cannot be profitable since we don't arrive, let's say, to at least 100 users or even more than 200, 300 users. It's necessary to have more users. And then it is going to create a job because you will need young technicians, people to go, and because in agriculture there is always something, every day you find something that doesn't work well. So you need always people on the field that go to adjust something in one side, another side, and so on. So this is our goal, and we hope we will find a way to reach it.
I would suggest to double check the period of stress of pitch because it was too long, and for my experience can affect the fruit quality. Just check, double check.
Okay, we agree. We will contact you so that we can adjust it. Because it is something,
Okay. Of course, we will have the chance to continue this discussion also in front of the system outside. We can do it. Okay. So if there is an okay.
I will just use different ideas from your presentation to ask who's gonna pay in the end the transaction cost. We saw that in your example, the project covered the costs to implement this idea, which is great, but still it was implemented to big farms. So if normally corporates are ready to move without any help, but the average European farm is the small or medium farm. So farmers cannot afford the transaction cost. Second, the EU, as we saw, is reducing money in agriculture, and they are trying in their common agricultural policy to reduce payments and direct payments, etc., in order to liberalize the agriculture. So, we have now also the trade negotiations between Europe and America, which would lead directly to reduce the environmental and to increase the liberalization of agriculture, which also would reduce, it wouldn't drive, as you showed in your graph, to move agriculture toward an eco-efficient agriculture. It would bring the curve back to the non-efficient agriculture. So who's going to pay the transaction cost? And there are really a lot of question marks for our future, the agricultural future.
Thank you. I presented before some thoughts about from farmers who already applied the system. They are satisfied, they would like to continue to use this system. And they are even ready to pay for using this system. But I said we need to reach economic advantage of that. So we need much more users than we have actually, and we are working on that. But the overall approach of agriculture is to go to a more controlled production systems and to go into the systems when money and income is going to be important and environmental burden to be reduced. Nowadays, if you see, European Union is also promoting through the new policies also the traceability of the products. And you have inside necessity, if you are going to sell something on the market, to present and to have a certificate of all agronomic practices that you applied on the field. Inside system like this one, you can really do it, because what we have inside, we are going all data related for one season, from the sowing to the harvesting, even after that, application of water, use of fertilizers, use of pesticides, everything is inside the system. So this is useful also from that point of view. What I really believe, it should be integrated system, having inside all data about the product, about 1 kilogram of fish that is coming from Basilicata. This is something, and it will be the future that I hope. And then we can put that eco-efficiency of that system was, and put the numbers. So have a sort of certificate of eco-efficiency of our agricultural products. So I believe the future of the system is in that direction.
So it's also in the direction of bigger farms?
Direction of bigger farms, of course, because it is something that is becoming also trend. If you go to see in Apulia, you have small farmers you have on the catastrophe. But if they are too small, if they are going to transfer from rural area to urban area, they are renting their land to bigger farmers, and they are producing more. In that case, they have economic interest to use this type of system. So this is also a good point.
Thank you very much. And now we don't have time for more questions. We will proceed to the next presenter, Dr. Z.